A warm welcome to this talk. Now, today we're going to be looking at a new paper which shows very promising results for ivermectin and mebendazole being used together in the treatment of a wide variety of cancers. Now, this is the paper here. Real-world clinical outcomes of ivermectin and mebendazole in cancer patients result from a prospective observational cohort. So in other words, this was a group looking forward, people joining the group and then data being collected prospectively as the trial goes along. And it's written as a full paper here. We have the abstract. It's not yet been subject to full peer review, but I'm bringing it to you because it's really very interesting. And the lead author is Nick Hushler, who is actually a friend of the channel. So the full paper is there. Now, let me just give you the main points of this, and you can decide if you want to watch. So that's the reference for the paper. The clinical benefit ratio. Now, the clinical benefit ratio is something used particularly in evaluating cancer treatments. And it means that there's a complete response, or there's partial response, or stability of the disease. It means it's a good outcome. Anyway, the good outcomes were 84%, with a combination of ivermectin and mebendazole. Mebendazole, of course, is a very similar drug to fenbendazole. It's the human form, really, mebendazole. Mebendazole and ivermectin together giving this good result of 84% in terms of clinical benefit ratio. So that's what this video is about. 84.4% of patients did well, which is incredible. So why isn't this being widely taken up? Well, we don't have the large-scale randomized controlled trials because they're largely done by pharmaceutical companies. Now, the paper does mention the fact that overall it is estimated that annual costs of standard chemotherapies average $111,000 per year. I guess that's about, what, £90,000. $111,000 per year. Now, the fact that the pharmaceutical companies are making so much money out of this may have nothing to do with the fact that they don't conduct the clinical trials into ivermectin and mebendazole. Who knows? But they're facts given in the paper anyway. Now let's look at some of the details now, because it really is quite an interesting study. So drug repurposing offers a pathway to identify accessible, this is available to anyone, this is egalitarian, low toxicity, low cost cancer therapies. Now the paper says that this therapy should cost $1,000 or $2 a year, as opposed to $111,000 per year for traditional chemotherapy. I'm sure I could do it for a lot less than that, one heck of a lot less than that. These drugs are generic, they're remarkably cheap. Before Romania joined the European Union, I used to buy a lot of mebendazole and send it to friends and colleagues in Romania for treating worm infections, parasitic infections. And at that time, okay, it's a while back, but I was paying £2.30 per 1,000 doses. That's probably the equivalent of £6 or £7, $10 per 1,000 doses. So these drugs are remarkably inexpensive, remarkably cheap, and have got the potential to, as we'll see, treat these wide variety of cancers. Now, ivermectin and mebendazole have demonstrated multiple target anti-cancer activities. They work in many different ways. I do see quite a few papers by, what do you call them, fact checkers, who say cancer is not a parasitic disease. Ivermectin, mebendazole, fenbendazole can't work. Well, this paper is aware of that. We're aware of that. They are not working by killing parasites. They have multiple other biochemical modes of action, and the details of those are coming. So we know that they work in a wide variety of ways in the cells and tissues of the body. This paper evaluates real-world patient-reported outcomes, safety and adherence to a cohort of cancer patients utilising the combination protocol. And the combination was ivermectin 25 milligrams, mebendazole ivermectin 25 milligrams, mebendazole 250 milligrams a day for 90 days. That was this particular protocol. We're not giving medical advice, just reporting what this protocol was. The methods, so it's prospective observational cohort study, 197 cancer patients, so it's a reasonable number. They were prescribed ivermectin and mebendazole off-label, so this is not official sort of nice guideline stuff, it's off-label, what you might call compassionate prescribing through telemedicine by registered US providers. Participants received compounded oral capsules, so it was all together in one, 25 milligrams of ivermectin, 250 milligrams of mebendazole. I think that's what I said before, 250 milligrams of mebendazole. Mebendazole, as we've said, being a very similar preparation to fenbendazole. Data were collected voluntary, standardised digital surveys at baseline and approximately 6 months follow-up. So these patients mostly followed up at the 6-month period. The initial cohort, 197 baseline characteristics, including cancer type and disease status, were assessed. And there's actually some really quite nice graphics in the paper here, where they show like prostate cancer was the most common, then breast cancer, then lung cancer, then colon cancer, liver cancer, and then all these other cancers as well, which in itself is really quite impressive, that this combination of mebendazole and ivermectin appears to be effective against a very wide range of cancers. And this means if you think about a third world situation, for example, where you don't have perhaps availability of specialist oncologists, junior doctors and medical assistants and senior nurses could potentially prescribe this for a wide range of cancers, because the treatment would be probably, as far as we know, very similar for a wide range of cancers, which is, again, very egalitarian and the sort of thing we want to promote. So various cancer types, a total of 122 patients completed, 61.9% response rate. So that's actually not too bad. Mean age 67, about half were male and half were female, so pretty well half and half. Cancer types included, I've listed them there just for convenience so you can see them in the notes. So as we've just noticed, a wide range of different cancers. Normally, of course, all these cancers would have, as I said, dramatically different treatments, whereas here it was all the same basic adjunct treatment that could potentially be given. Median duration since initial diagnosis of these patients was 1.2 years. 37.1% at the time were experienced active disease progression. So that was shown on this graphic here. So we see that at baseline we have 37.1% who were actively progressing. That means the disease was metastasizing. Metastasis going to different parts of the body, spreading all over the place, to the bones, the lungs, the brain, wherever it the liver, wherever it was metastasizing to. Others were in a more stable situation at the time. This is when the treatment was, when the patients first enrolled on the trial. 6-month follow-up, pretty good, nearly 87% adhered to the treatment. Took the full 90 capsules of ivermectin and mebendazole prescription. So not an intensive, difficult treatment to follow at all by any means. Clinical benefit ratio, as we've said. So some had complete response, some had a partial response, and some had the disease was stabilised. And again, the paper's very good. It shows this graphic of that. So we see that some patients here, the 32.8%, had no evidence of disease at the time. 15.6 had known regression and 36.1 were stable. Only 15.6% had progressed. And given that cancer is a progressive disease, I consider that result to be quite remarkable, really. Normally, of course, you'd expect 100% to progress because cancer is by definition a progressive disease. Clinical benefit ratio, as we've said, 84.4%. Right, so 48.4 of the cohort, strongest possible outcomes. Regression, 15.6%. No current evidence of disease, as I said, 32.8. Disease stability, 36.1. Only 15.6% of the whole cohort were progressing, which is remarkably good. Remarkably good. 87% nearly stable or improving. Now, this is very interesting indeed. I have talked to different people on this channel Dr. Makis in Canada, for example, Gustav Gleisch in the UK. And we've talked about the dose which would be ideal for this. And basically, of course, because the trials haven't been done, we don't know. But this study, at least relatively small, but what this study showed is no significant dose-response association was observed for cancer outcomes. And the chances of that being wrong were only 9%. So it's 91% likely that that is a correct statement. In other words, the lower doses, people on the lower doses were doing as well as people on the higher doses. Now, the very best response was from people with 2 capsules a day, but it wasn't much different. So it looks like the relatively low dose of 25 milligrams of ivermectin and 250 milligrams of mebendazole is as effective as the higher dose, at least from this study. Now, of course, people will argue with that. All I'm saying is I don't actually know the complete answer to that. Of course, no one does, because the full trials haven't been done. But that's what this study showed. It's a direct quote from the study, very interesting. No significant dose response. So I mean, not normally with a dose response, it's like if you give a higher dose, you get more response. So the higher the dose, the greater the response. So, for example, if someone's drinking alcohol, the higher the dose of alcohol, the more they get drunk. That would be normal, but this isn't showing that. So the response was pretty well the same in this study, regardless of the dose, which is very interesting indeed, and should help to guide future studies. Without any clear dose response gradation for efficiency, encouraging that the lower doses may be effective. How low can we go? We don't know. But it would be interesting to find out, wouldn't it? Side effects, pretty mild. There were a few mild side effects reported, mostly gastrointestinal, but nearly 94% of those affected were able to carry on with their treatment. So very well tolerated. Some adjusted the doses a bit, but basically very well tolerated. Concurrent conventional therapies. Now, what other therapies were these getting? Well, of the people taking the ivermectin and mebendazole, 27.9% were on chemotherapy as well. Radiotherapy, 21.3% were on radiotherapy as well. And 19.7% had surgery during the course of the 6 months as well. And as well as that, quite a lot were on dietary supplements, nearly half, and dietary modification, just over a third. Right, conclusion. The initial conclusion from this study. In this prospective real-world cohort, the combination of ivermectin and mebendazole was associated with high rates of self-reported clinical benefit, with nearly half of participants reporting tumour regression or no current evidence of disease across heterogeneous populations of cancer patients. In other words, different people, different sexes, different types of cancer, all got a benefit, which is really quite remarkable, These findings provide a compelling clinical signal that there is well-tolerated, repurposed agents may offer therapeutic benefit. That's the ivermectin and mebendazole may well offer therapeutic benefit. However, as the study honestly says, observational design, reliance on self-reported outcomes and potential for selection bias, that's the people that go into the study in the first place, and uncontrolled confounding variables, these findings should be interpreted as hypothesis generating. So there is most definitely a hypothesis here. The hypothesis is that giving 25 milligrams of ivermectin and 250 milligrams of mebendazole every day for 90 days has a significant benefit to a whole range of cancers. That is easy to test. Now, of course, we're not expecting this to be done because mebendazole and ivermectin are cheap. They're inexpensive. And pharmaceutical companies are currently making an average of $111,000 per year per patient. Not that we're saying that's why they don't want to do it. They could be completely unrelated facts, of course. It just drives you mad, doesn't it? These studies are crying out to be done. The hypothesis is clear from this and multiple studies. We could be curing, potentially, we don't know, but we could be curing your wife's cancer, your husband's cancer, your mother's cancer, your father's cancer, your son's cancer, your daughter's cancer with ivermectin and mebendazole, but the trials, the randomised large-scale double-blind controlled trials are simply not being done. In my view, this is an outrage and an insult to research. But it's currently our situation, unfortunately. Validating of these observations further define optimal dosing strategies. So yeah, we need the trials because we're really not sure what the best doses are at the moment, although we have seen, promisingly, as we've said, that the lower dose patients in this study with the lower dose of ivermectin, the lower doses of mebendazole, were doing as well as the patients on higher doses. Now, does this make any sense? Is there a pharmacodynamic rationale? Is there a mechanism by which these drugs work? Yes, absolutely, there is. Very much so there is. Ivermectin and mebendazole are antiparasitic agents, but that's probably not how they're working in this case. As well as, so this is a plus, demonstrating highly promising anti-cancer activities. Ivermectin, for example, shown to exert over 14 distinct anti-cancer mechanisms across 12 cancer types. So 14 clear biochemical mechanisms have been identified via which ivermectin could be preventing cancers in 12 different cancer types. This is incredible. Working in 12 different cancer types. How is it doing it? Inhibiting cancer cell proliferation, so stopping cancer cells multiplying. Reducing the likelihood of metastasis. Angiogenesis, so angio is blood vessel, genesis is beginning of. So for a cancer tumour to grow into a large bulky tumour, there needs to be angiogenesis. There needs to be production of new blood vessels. If there wasn't a blood supply to the cancer, it would go black and die, like tying an elastic band around your finger. It would go black and die and necrose. So it looks like ivermectin is inhibiting the growth of new blood vessels to new tumours. If there's no blood supply to the new tumour can't grow. It's very, very simple, very, very obvious. And also reducing mitochondrial function in cancer cells, the ability of the cancer cells to produce energy. Has demonstrated excellent safety in cancer patients, including those undergoing chemotherapy. So, in other words, this drug has demonstrated very high levels of ivermectin has developed high levels of safety, to demonstrate high levels of safety, used on its own and used with other chemotherapeutic agents. And I myself took 12 milligrams of ivermectin a day for 7 weeks with no side effects whatsoever. Just to try it on myself, really. So even with people taking chemotherapeutic agents as well, it's not a contraindication. So if it's potentially beneficial when people are taking chemotherapy, why not give it as well? Why not give it as well if it's not doing any harm? And there's no harm being indicated by this paper at the moment. Ivermectin and mebendazole selectively target cancer stem cells. So these are the stem cells, are the cells that grow into cancer. So like a stem cell will divide into two. It will divide into two cells. One cell will remain as a stem cell, while this other cell here will divide into a population of further cells via simple mitosis. So you get a population of cells here, carry on dividing. Of course, tumours contain billions of cells. So that carries on into a population. Meanwhile, this stem cell can sit around, but then at a future date that can divide again into a further stem cell and into another proliferating cell, which again can divide into a population of cells, as we've already seen. So ivermectin and mebendazole selectively target cancer stem cells, which is exactly what we want. If we get rid of the original stem cell, then none of those offspring cells, daughter cells, can exist. Mebendazole particularly, microtubule disruption leading to effective cell cycle arrest. What happens here is, here we have a cell that wants to divide, and the chromosomes come into the middle in pairs like this. There's pairs of chromosomes like that in the middle of the cell, and they duplicate. They duplicate, and then there's a bit here and a bit here, and then a spindle forms there, connected to the chromosomes. And what these spindles do is they contract, and they pull these chromosomes into one half of the cell. So those go into that half of the cell. These ones are pulled into this half of the cell here, so they end up over there. So what you end up with is, from having an initial cell, you end up with a cell in the stages of mitosis with all the chromosomes there, from duplicated there, and all the chromosomes duplicated there. Then all this cell has to do is pinch off into two cells. So it pinches off into two cells, so you have a situation, it looks a bit like a dumbbell for a while like that, with the chromosomes in each. And then it splits completely into two cells. But that's dependent on these microtubules pulling the chromosomes into the two daughter cells. And if those microtubules don't form, that can't happen, so the cell can't divide. Wonderful, because we don't want cancer cells to divide. Of course. So microtubule disruption is one way it works. Potential to induce apoptosis. Apoptosis is when a cell just kills itself, cell suicide. And they just pop into essentially non-existence by releasing digestive enzymes which auto-digest the cell. Significant inhibition of tumour growth, inhibition of angiogenesis again, and disruption of glucose intake so the cell can't metabolise. And when used together, they target non-overlapping pathways resulting in synergistic tumour regression. In other words, ivermectin will target some cancer pathways, mebendazole, or indeed febendazole, but mebendazole in this case, will target other pathways. So between the two of them, they're clobbering a whole range of cancer pathways. Now, one on its own might work for some cancers, but because you're attacking so many different carcinogenic mechanisms, the chances that if you give the two together, it's going to kill the particular cancer you're suffering from are greatly increased, according to this way of thinking. So, non-overlapping pathways, synergistic tumour regression. Synergistic, of course, means it's more than the sum of its parts. Cancer stem cell reduction and reversal of multiple resistance in multiple in vivo and vitro models. So if you give just one or two drugs, the cancer cells can become resistant. But if you're attacking the cell via 20, 25 different mechanisms, okay, the cell might become resistant to one or two or three or even four of them, but not to all 20 of them. So you're going to kill the cells before they can possibly develop resistance to such a wide variety of biochemical attacks from the ivermectin and the mebendazole. That is the thinking there. And it makes perfect pharmacodynamic sense, to me at least. And we know they're well biodistributed. They go over to all the tissues in the body. So wherever the cancer is, they should get there. Perhaps with the exception of the central nervous system. I'm not sure about that. And again, the article, if you want to read it, free PDF to download. It explains here the anti-cancer mechanisms of ivermectin and mebendazole and the way that they attack various tumours using various mechanisms. So there we are. This research needs to be done to know if this is all correct in the larger scale clinical trial situation. It's probably not going to be done, which of course is a complete utter disgrace and a complete tragedy to those people suffering cancers. Could be me, could be you, could be a family member. Just let them die if they can't pay the $111,000 a year. You know, what the heck? I don't know. Why aren't governments doing this research? Why aren't independent universities doing this research? Just because there's no money in it. Is that why it's not done? Let me know what you think. Let's close with phenomenal frustration, but at least you watched, so thank you for that.
So if you wind the clock back just a few years ago, we were all told that if you said the word ivermectin, that you'd be outcast. You might be kicked off of social media for mentioning that there was potentially a curative or a treatment out there for one of the most harmful pandemics we'd ever seen in world history. You can't mention it, though. You can't talk about it. Certainly on X, you couldn't talk about it on Facebook. You couldn't talk about it on YouTube. If you brought it up, you might get a warning. You might get pulled down. You might get banished. Remember, Jimmy Kimmel told us on live television that it was horse paste. He's making fun of Joe Rogan for taking ivermectin. So the largest published story, the largest study ever of human ivermectin cancer study just rolled out to date. And turns out that nearly half of the reported cancers in these patients disappeared or had massive regression after 6 months of treatment. I'm sure they don't want you to know about that. Person largely responsible for helping to get this study out there is Nicholas Hulscher. He's an epidemiologist and administrator at the McCullough Foundation, and he joins us now. Nicholas, great to see you. Welcome back to the show. And it seems like the term ivermectin, at least over the past year, is popping up in far more places. And people that were once telling us that you should avoid it, this is horse paste, are now embracing it. What do you think has changed?
Well, first of all, thanks for having me. And you're right. This ivermectin, antiparasitics, Membendazole, Membendazole have been demonized by the biopharmaceutical complex, the vaccine cartel, and the chemo cartel now because it threatens their massive profiteering model of profiting from cancer patients and vaccines. Because if we go back to COVID-19, if they admitted that ivermectin was at least partially effective, they would have never have been able to emergency authorize the mRNA gene transfer injections. And so they claimed it didn't work. And now we have over 100 studies showing it did work for COVID-19. It reduced hospitalizations, cases, and time to resolution. So they were completely wrong there. And now they're also completely wrong in that it's just horse paste for cancer. We did just publish on the preprint server hosted by Zenodo, which is operated by the European Nuclear Agency for research. And what we did was, well, first of all, it's important to note what led up to this. For about 50 years, there has been sparse animal evidence, some case reports of antiparasitics in cancer. In fact, in the 1950s, the CIA actually classified a document in the 1950s that was showing antiparasitics had anti-tumor effects. They declassified it in 2011.
What?
Basically, yeah.
Hold on. I'm sorry. The CIA, 50 years ago, knew that there was evidence that taking an antiparasitic like ivermectin could reduce tumors, and they classified it and hid it?
Correct. It was a Soviet study. These Soviet scientists found that both tumors and parasites and these antiparasitics exerted similar mechanisms, and they found that it exerted anti-cancer activity in animals. And that study was classified by the CIA in the 50s or 60s and not declassified until 2011. So, that did significantly set back some of this vital cancer research.
I'm just sorry, before you go on, what would have been their motivation for hiding that information from the American people?
There was lots of motivations to hide possibly effective cancer treatments that were non-patentable and cheap. And that's exactly why it appears they may have classified it. They didn't want some cheap, safe, and effective treatment for cancer. They just wanted the conventional cancer treatment model to go and propagate for 50 years, costing millions of cancer patients' lives, as many have suffered from chemotherapy.
That is just... the CIA is obviously incredibly demonic, one of the most evil organizations, criminal organizations in the world. But this just took it to a whole nother level for me. Like, I was already convinced about how demonic and horrible that organization was. And now to hear that they knew about this and kept it from the American people is absolutely horrifying. And of course, playing into the biopharmaceutical, you called it the chemo cartel. And when did we see the rise of, I want to get back to ivermectin here in a moment, but like you want to talk about context here. When did we see like the rise of the chemotherapy cartel?
Yeah, that was around the same time. I believe 50s, 60s, 70s is when we really started to see the rise in these conventional treatments. And then we got to radiation. You know, they've always done surgery. So they've been around for a very long time and have largely remained unthreatened unless there was another novel biological agent that was very profitable and patentable. Those were allowed to come in. Some of these gene therapies, you know, these immune checkpoint inhibitors, you know, all these other things are allowed to get in. And again, they're not very effective. They're not curative. And so, yeah, you know, it began a long time ago, but now the tide is turning.
I think so. And so can you just explain to our audience, like, what happens still currently without even ivermectin or membendazole being involved in some sort of a treatment? But let's say, like, you know, someone you love gets cancer and they go through like a chemo treatment. Can you like walk our audience through? And I'm sure so many of people watching right now have had someone that has cancer in their life that went through chemotherapy. We all know somebody. Can you talk about, number one, how much that costs, who benefits, and what is it actually doing to the patient?
Yes. So chemotherapy costs on average to the patient, after all, you know, the hospital costs, administration costs, drug costs, over $100,000 in a year. The ivermectin and membendazole, a few grand, or even less, depending on where you source it. And so, you know, you see just how expensive it is. And we have to remember the clinical benefit ratio. So how many people benefit from chemo overall? It ranges depending on the cancer from like as low as like 20%, 10%. It can get up to 50, 60% in some cases, but that's quite low, particularly now when we talk about our study on the ivermectin and membendazole was an 84.4% clinical benefit ratio without destroying the entire body, because that's what chemo does. It kills all the cells. All rapidly dividing cells are destroyed, including healthy cells. And that's why, unfortunately, some of these cancer patients end up kind of withering away. Their last months of their life are absolutely dreadful. They feel worn down as these cytotoxic agents, particularly doxorubicin, it's called the red devil, that just destroys the body. And at most, this chemo can extend life, survival time by maybe a month or two, sometimes decreases the survival time. And so, you know, we got to find these alternative methods.
All right, so let's dive into ivermectin here in your study. Is it ivermectin alone, or is it matched with membendazole? And can you walk us through what your study found?
Yes, so this was the single largest human study on ivermectin and membendazole in cancer patients. Before, we had a few case reports, we had a few case series. In this paper, we had 200 cancer patients with active cancer. 36% had active metastatic cancer. The rest were not currently spreading, but they had tumors. And what happened was, through a telemedicine platform, the wellness company, these cancer patients were prescribed off-label these ivermectin and membendazole compounded capsules. So it was 25 milligrams of ivermectin in each, 250 milligrams of membendazole in one capsule. The most common dose that these individuals reported to have taken was 1 capsule a day. Some took 4. They had more side effects, though, primarily gastrointestinal. And so we did a survey, a baseline survey. We collected all the cancer information, all the cancer types. There was so many, over 20 cancer types in this cohort, which was what makes it real world and applicable. The most primary cancers were breast, lung cancer, and then we had thyroid cancers, pancreatic cancers, lymphomas, leukemias, all sorts of cancers. And then after 6 months, we did another survey. And these patients, and about 60% responded. That's a very high response rate, by the way. And of those who responded, 84.4% of them did report to have benefited in their cancer, particularly about half, 48%, did report their cancer disappeared or the tumor shrank. And 32% or 36% reported that their cancer stabilized. So it wasn't spreading, it was staying stable. And so that's what makes up the 84.4% clinical benefit ratio. Now, there was 15% where it did progress. Now, so it doesn't have 100%, effectiveness rate here or benefit rate, but 84.4% is much higher than all of these other pharmaceutical agents, chemo, radiation, etc. It's extremely promising. And now we need double-blind randomized placebo-controlled trials. This study has to serve as the springboard. They have to be initiated immediately.
Well, here's something that'll make 80%. Well, I'm sure you'll get enormous pushback from the industry, the chemo cartel, the biopharmaceutical complex that makes, because at the heart of it, maybe you can explain to our audience, like ivermectin, I mean, it's won the Nobel Prize in medicine for going back, and it's decades old, right? So maybe you can explain to our audience why there's very limited profits for ivermectin for these companies, like the biopharmaceutical cartel with all the vaccine, everything else they've got going on. They really won't make any money off of this, right?
No, they won't make any money. Some of them may hop on and make some, generic ivermectin pills, but that's not going to be very profitable for them. And particularly ivermectin was discovered, I believe, in the 60s or 70s by a Japanese scientist. He literally isolated some bacteria from a golf course. Can't even make this up. He isolated the compounds in it. He found what was called ivermectin. And then from ivermectin, they were able to make it a little bit safer in humans to what's called ivermectin now. And so it is it's derived from a natural source. It's not some completely made up synthetic agent. And that's why we see higher safety profiles with this. And so that's what makes it particularly interesting.
So what does it do to the body? If I'm 49 years old, in fact, our friend of the show, Dr. Peter McCullough, they just sent me I'm doing the parasite cleanse, the Ivermectin and Membendazole, and I've told my father-in-law about it, with like brain fog and other things. Like I'm singing it I'm starting the process. But anyway, what is it doing to the body? If I just take the Ivermectin, what is it doing in my body?
It's doing a lot of things. First and foremost, it definitively eliminates parasites. It literally cuts off their vital cellular energy production. It cuts off what they need to survive, and it kills them. It eliminates them. So it's good. It's great for eliminating parasites. That's why it won the Nobel Prize, in 2015, because it cures river blindness, all sorts of things. And so it's been very effective for that. But when we talk about cancer, what it does is very, very interesting. There's now over 100 preclinical studies that have looked at ivermectin, membendazole, fenbendazole in animals or in the test tube. So the animals, they'll implant them with tumors, or in the test tube there will be human cancer cells. And they found across these hundreds of studies now, there's over 12 distinct anti-cancer mechanisms with these antiparasitics across more than 12 cancer types. And in particular, the main mechanism of ivermectin is it targets what's called cancer stem cells. And this is literally the source of some of these cancers. Like sometimes you'll get rid of the tumor with, chemo or radiation, but the cancer stem cells are still there. And so they're going to come back. The cancer is going to come back. You eliminate those, they're not going to come back. Ivermectin targets them potently. And then membendazole particularly targets what's called microtubules in the cancer cells. That's crucial for cellular division. And so you cut those off, they won't be able to divide anymore. And so, again, very strong mechanisms. And then two more things. Membendazole and ivermectin inhibit what's called glucose metabolism in these cancer cells. So, cancer cells love to feed off of glucose sugar. You cut off that metabolism, they won't be able to take in the sugar and glucose anymore, and they'll shrink. And so that's what they find in the experiments. And so that's why it's not surprising why we see these results in the first real-world human study.
So if you don't have cancer, you can take this really as a preventative for cancer? Do we have that direct link yet between parasitic infection and cancer? Maybe the CIA did 50 years ago and they hid it from us.
Yeah, we think in at least a subset of cases that parasites could be a root cause of some of these cancers. We don't know how many, what percent, but it could be playing a role for sure. We know that they operate with the similar mechanisms, parasites and tumors, and that is particularly why we think it works, but it also could be because there are literally parasites in these areas of cancer. It's a mix of so many things because there's so many different types of cancer, and so it's hard to really pinpoint, one single cause. But we know, we want to target as many mechanisms as possible, and these antiparasitics do that across 12 mechanisms.
So can you explain the mechanism here with a parasite? You get a parasite, whether it's from eating, I don't know, raw fish or some food or out hiking or something. I don't know how you're getting these parasites particularly through the environment. Maybe you do specifically. And then how is it causing a replication of cells in the body? I'm thinking of a parasite like a tapeworm that's just kind of living off of the food that I'm feeding it.
Yeah, so the mechanism behind that, well, first you would get the parasite. Sometimes you get it from eating raw food, sometimes sushi. This is a big culprit. If you have a cat, and you go in their litter box often, or, you go swim in some river and it's littered with a bunch of parasites, you swallow some of that water. So there's many different transmission routes to become infected with them. And so that's that. And so how they could cause cancer, well, if they do kind of attach to certain tissues, certain organs in the body, and they begin to kind of feed off of those cells, damage them, and cause all sorts of cellular and biochemical havoc, that may very well trigger some sort of uncontrolled cell growth mechanism in those tissues. Now, I don't know the exact mechanism.
Because they're trying to prevent the parasite, so they're replicating in order to try to stop the parasite?
Yeah, it could be the body's own way of actually defending against the parasite. Exactly. So again, it could be that. It could be because the parasite's causing all sorts of biochemical havoc, gene expression havoc, resulting that way, or it could be a defense mechanism. So it could be many different things.
And then the ivermectin, I've read it to paralyzes them. Is that right? It paralyzes. Is that how? Or it kills them, paralyzes them, and the Membendazole, to your point, then basically helps get rid of them completely from the system. Is that the process?
Well, Ivermectin and Membendazole, they'll target different types of parasites. Some are more effective against certain types than others. But what they all do is they do literally go into the central nervous systems of these parasites and, kill them, paralyze them, shut them off. And so, and they're almost, extremely effective for parasitic infections. But when we talk about cancer, Membendazole appears to be the more potent one.
It's unbelievable. So what, and I guess for a preventive, I want to come back to my preventative question. Like, if I'm, by all accounts on the outside, I'm healthy, I think, but who knows what kind of parasites I might have inside of my body. If you're eating sushi, other things, you've been swimming in a lake, who knows? And you start this parasite protocol, an Ivermectin, Membendazole, parasite cleanse or whatever. How long does that protocol last?
It can take a week. Sometimes they're only a week. Sometimes they're a few days. But most occasionally, about a week, 2 weeks. If you are confirmed or heavily infected, it could be a month. And then when we get to cancer, it can be longer than that, 6 months or a year. And so, it kind of ranges. But, for somebody that just is suspecting they have, parasitic infections, a week would be sufficient. But again, I'm not a physician. I can't give medical advice, but that is what many people commonly report to take, and as well as the instructions indicate that.
And what does it do to the body? Like, if do I start to feel better almost immediately? Is this something that I feel maybe better after a week or so? Maybe it's brain fog. Maybe you don't even know you have parasites, but you're doing it as a preventative measure. What have you seen in your your studies and reporting from different patients?
Well, if you're infected with a bunch of parasites, yeah, you can have lots of fatigue, lots of brain fog, weakness, and sleep disturbances. You can just feel off. And if you did truly have those parasitic infections, you take the antiparasitics, you should, if you were infected, feel remarkably better if that was the cause of those symptoms. And yeah, you would have less brain fog, less fatigue, etc. And so, it would be very beneficial, and it always is, to clear out those parasites. And so, yeah, it does do that. Now, if you take too much, and some people do get some side effects with the antiparasitics, very mild, in fact, it's safer than Tylenol. But what can happen is you can get some gastrointestinal upset. You can get a stomach ache. In our study, about 25% reported mild side effects, including the stomach aches. And then you can get dizzy, particularly if you take like 4 capsules in a day. That can result in some dizziness. So, it's not completely free of side effects, but, they're very, very mild.
Yeah, I imagine if you're taking it on like an empty stomach or something, like maybe you want to eat some food with it or whatever. This is fascinating. And obviously the cancer study is at the heart of this, but I'm just fascinated from this idea that we've known about this parasitic connection to tumors going back to the CIA classifying this information. How often, I know you're not a doctor, you can't get medical advice, but is this something you would want to do like once a year to your body? Go through this cleanse, like maybe once a year, maybe twice a year, just to make sure especially if you love sushi. Like my daughters freaking love sushi. My wife loves sushi. And in fact, lately, she's even been like, man, I just feel like I can't put sentences together. She's like, I'm super sleepy. And I've been seeing these sushi studies and ivermectin. And I said, all right, we're getting you a parasite cleanse because I don't know what's going on, but you're like falling asleep at like 8 o'clock at night, like what's going on here? So anyway, how often should you be doing this?
Yeah, well, for a healthy individual that does, eat sushi or, goes in rivers, in the middle of nowhere often, or goes in just lakes and swallows a bunch of water, or, you're in, outside often in the forest, or, whatever, you're doing stuff that's exposing you to the wilderness or the outdoors. Once a year could be something. That's something that I would do, particularly if I eat sushi. I eat a lot of sushi as well. And I would say just as a preventative measure, I would personally try it out once a year, given that I'm exposed to some of these transmission vectors of parasites. Now, if I wasn't exposed to any, I would be less, adamant. But me personally, I think once a year would be sufficient. But if you're highly exposed to some possible parasitic environments, I would say, it could be more frequent every 6 months.
So back to the study, and before we let you go, now the next step, as you mentioned, pushing this towards like massive, I guess, like clinical trials, right? Control groups, placebo, all of that. Who would spearhead that? If like big pharma doesn't stand to benefit from that, how would we get one of these big studies?
Good question. We need the government to finally do something. We need the NIH. We need, the National Cancer Institute. They got to start running these trials with the taxpayer money. I think taxpayers would be happy to fund a study like this personally, instead of many of the other things currently ongoing. And so, we need a study that is non-biased, that is not going to, result in, falsification of the data, as we might see if some large pharmaceutical companies did such a study to kind of defame it or debunk it. So we need, an independent, large-scale, randomized, double-blind, placebo-controlled trial. The government can do it, and they've got to do it, because this is one of the most promising clinical benefit ratios that we have seen, particularly for a safe compound like this. And so once that occurs, then this can start to be incorporated into some major guidelines, etc. But we're going to have to get past the chemo cartel.
Hopefully people can tweet this out, tweet it at Bobby Kennedy, pushing to see if we can get this study, because how much does a study like this cost?
Clinical trial could cost hundreds of thousands, maybe millions. It depends on how many patients you have. So it can be very expensive.
That's okay. We spend $1 billion right now in Israel's war against Iran per day, $1 billion per day. So I think we could maybe use some of that money, right? Or
yeah,
take some of the war money and try to cure cancer in the United States. Just an idea. Hope the administration is paying attention. Nicholas, where can people learn more about this study if they want to dive more deeply into this ivermectin data? Especially if they have a family member that's, maybe just was diagnosed with cancer. And by the way, can I just ask you before you go, like the cancer strata, was it like stage 1, stage 4? Like how far gone was somebody with cancer when they responded and found that it made their tumors disappear?
Yeah, so it was so again, about 37% had active metastatic cancer. So that'll be stage 4, stage 3. And then, about 60%, 50-60% were stage 1, stage 2. So it was a wide variety. And so it appeared to have resulted in no evidence of disease and even advanced cancer patients. But again, we got to do more study. Our next study is going to be larger sample sizes and specifically looking at each cancer type and staging status. So we'll be able to see exactly what is occurring there. But yeah, so far it's been a wide range and it's very promising. But one last thing that's very important is, a lot of people, they still want to take chemo, they still want radiation. And our study showed, about 20% were taking chemo, 20% radiation, 20% surgery. It was very safe. The ivermectin and membendazole was very safe in those undergoing conventional treatments. And so that's what's important. So people, they can still do the conventional way, but this is actually can be an adjunct to that therapy. So that's what's very promising as well.
Yeah, so if people still want to take chemo, I don't know who would want to do that, but have all your hair fall out and your body is being poisoned, okay. But yeah, you could still do that, and you could still do the radiation, and then also consult your doctor about ivermectin and membendazole as part of that whole process. And it just really saddens me because I've had friends who've lost loved ones to cancer, over the past few years. And if only they had access to this information, would they still be with us? And that's just, we can't really ever wind the clock back, of course, but it's just sad to think that you had a government that knew this information, was keeping it from us, and family members who passed away because they didn't have access to this free and open information and cheap and really effective medicines.
Yeah, millions of cancer victims have paid the price as a result of suppression or ignorance or just disastrous decisions to censor this stuff or not do the studies. And so finally we're doing them. Hopefully we can start to reverse this. Cancer is the second leading cause of death in the world. We got to stop it. And this appears to be one way we may be able to help stop it. And so it's very promising. But you could check the study out. There's multiple places you can go. You can go to twc.health/cancer, and you'll see a breakdown of the study and everything. You can go to the Zenodo preprint server where the study is hosted. And you can find the link to that on my personal X account at NIC Hulscher, HULSCHER. You can also follow me on thefocalpoints.com. That's our Substack publication with Dr. Peter McCullough and John Leake as well as myself. So you'll find all the links there. And one last thing, my personal website, nicholaszhulscher.com. You can find it there as well.
Awesome. Thank you, Nick. I really appreciate you joining us. Really appreciate you sharing this new study with us. And hopefully this will help somebody in our audience, or hopefully help thousands of people in our audience. I really appreciate it. Thank you so much, Nicholas.
Thanks for having me.